So for this video, explain the experimental setup and our final project demonstration for our thermistor circuit. So if I can swap the camera, here is our thermistor circuit. You can see we have our breadboard, our LCD display, and our microcontroller. We've also got our 10 kilo ohm thermistor and a voltage divider with a 10 kilo ohm resistor. This potentiometer here is what allows for the LCD screen to be read correctly. And here is our active buzzer, which is set to sound whenever our temperature reaches a set threshold, which we have set to 80 degrees Fahrenheit. So this thermistor will send a signal to our microcontroller, which will then take that signal and calculate the different temperatures in Celsius and Fahrenheit. And we'll also tell this buzzer once we hit 80 degrees to sound. So I will go ahead and demonstrate here. Let's get this to focus, showing the thermistor hit 80 degrees Fahrenheit. So as you could hear, the buzzer did sound when we hit above 80 degrees Fahrenheit. Now, so for our calibration of our circuit, we used two different temperatures of water in a sealed bag like this. We set the sealed bag on top of a thermometer and waited until that thermometer read a steady temperature value. And once it did, immediately after reading a steady value, we then set that sealed water onto the thermistor and waited for it also to reach a steady value. And once we got those two values for each different case, we did the percent differences. And I believe our largest percent difference was about 0.6. We were 0.5 off of temperature in each case. So 0.6% difference between the two cases. Very accurate. It meets all three of our objectives of being accurate plus or minus 2 degrees Fahrenheit, which we were well below that. It has an audible alarm, which you just heard when the temperature reaches 80 degrees Fahrenheit. And we have a clear digital output, which you saw of Celsius and Fahrenheit.